Oh, I think WebEx updated and it says this meeting's being recorded every time. Welcome. It's been a while since we've met. Um, it's quarter three, part of semester two. It's a fresh start for everybody. We've only got a couple people in the meeting, maybe a few more will join. Otherwise, again, if you're watching the recording, welcome. It's good to see everybody. Hi, Cardon. So what I was gonna do to start is kind of just reiterate expectations, just kind of relook at Schoology because we do since at the semester turn we got a lot of new students. So there's gonna be, there's a lot of people that maybe haven't done Link 12 or algebra yet, algebra 2 online yet. So just gonna review. Then we're gonna talk about arithmetic and geometric sequences and series. Look at some formulas. Then we'll do some practice, get into do a quizzes, and we'll recap everything, talk about our Class Connect assignment, and you guys will be on your way. So just to start, I want to go over Schoology. Let me get it pulled up here. All right, make it bigger. All right, so this is our class page. And if you're ever stuck or you really don't know what to do, you should look at the pacing guide because this is going to tell you everything you should be doing for that day. So if we look today, if you're in the meeting right now, awesome. If not today, at some point, you got to watch the recording and do the Class Connect assignment. I am actually going to be, so every, we about at least once a month, we do an in-person drop-in day. So if you ever have questions or you're struggling or you just want to go in and talk to someone, that's going to be me tomorrow. So again, I can help you in math, I can help you in another class. We can get in touch with your teachers, but my shift, it's my turn. So I'm going to be one of those people. We've got a few more people joining us. So let me make sure I let them in. All right. There we go. So hello, welcome. If you're joining us again, this is for Algebra 2. We were just looking at the pacing guide. So again, you can find that right here. And then what again, my expectation is this is where the recordings are posted. So if you're not, if you ever have to miss, this is where you can find the link for the recording. So like in a normal week, like if we look at week 1, okay, I want you to watch this video and take notes. So there's lots of ways to take notes. You can download this, you can print these out, you can just copy what I do on the videos. It's totally up to you how you take notes, but there's a lot of research that says taking notes helps. So you're going to watch this video and then try the assignment. Then you'd move on and say, okay, next day, I'm going to watch this video and take notes on lesson 2, and then I'm going to try the assignment once I'm ready with that. We love IXL. Okay, IXL is great. If you have troubles getting logged in, let me know. I'd be more than happy to help. All right, can I move this? There we go. I've got a quick video that I want to show you to review and just get our minds in this arithmetic versus geometric idea.
Hey guys, so in this video we're going to have a look at the difference between arithmetic and geometric sequences. So up the top we've got a 6-number arithmetic sequence, and down the bottom here we've got a 6-number geometric sequence. So when we're talking about arithmetic sequences, they are sequences which move by a constant. A constant, and this is referred to as the common difference. There's another video about that if you want to have a look. So common difference. So as you can see here, we start with the number 3, then 6, then 9, then 12, then 15, then 18. So if we want to find the difference, or the common difference, we can use the 6 minus 3. So 3 to 6 increases by 3, 6 to 9 increases by 3, 9 to 12 increases by 3, 12 to 15 increases by 3, and 15 to 18 increases by 3. So we move up by a constant every single time, and we call this the common difference. So for our geometric sequence, we're moving by a constant ratio every single time. So it's this idea of a constant ratio. So if we come down here to our geometric sequence, we've got the same two first numbers as our arithmetic sequence, but we can see that 3 to 6, that's 2 times, 6 to 12, so that's multiplying by 2. 12 to 24, that's multiplying by 2. 24 to 48 is multiplying by 2. And 48 to 96 is multiplying by 2. And we call this ratio here, so the fact that it's doubling every time, that is what we call the common ratio. So geometric sequences, we're always scaling up by, say, a factor of 2. And for an arithmetic sequence, we're always moving up by a constant. So if we wanted to kind of graph these and have a look and see what I guess both of them look like, we can just draw some axes down here. So we can draw these two axes. So for our arithmetic sequence, we know we start at 3. So for both sequences, we're going to start at 3, and then we're going to move to 6, then we're going to move to 9, 12, and it's going to form this perfect straight line. So arithmetic sequences will form this perfect straight line because they're always moving by this constant. So 6, 9. But if we look at a geometric sequence, so it starts at 3, and then the next point is 6, but then the next point is 12 after that, and then we've got 24 after that. So we can see geometric sequences kind of have this curved shape. So geometric sequences have a common ratio and a curved shape, whereas arithmetic sequences move by a constant and then they have this constant shape up over time. So that's the difference between the two. I'll go into more detail and I'll put out a video for each one. Thanks, guys.
Okay. So again, just getting our minds in that arithmetic versus geometric mode. And then building off of that, we've got these formulas that we use to, help solve, to figure out unknowns. So let's take a look. And this is something where if you don't have some of these things written down, you should definitely take some time to write these down right now. So if I'm looking at arithmetic first, if I have a sequence formula of nth term, I can use this formula on the right to figure out, hey, whatever term it is, again, I've got my A value, which would be my first term, and I've got my D, which would be my common difference, like we just talked about in my common difference. Saw someone in the chat box. Yes, a lot, very much like that. And we would probably say for like, we don't usually describe it as division. We would say if it's like getting smaller by dividing by 2, we would call it multiplying by 1/2. So technically they're the same thing. But usually and so like same with addition and subtraction, we wouldn't say we're subtracting, we'd say we're adding a negative, and then we can just keep it with multiplication and addition. But you got the idea. Awesome. And then if you're trying to find for the sum of n terms, so again, if I want to add the first term and the second term and the third term and the fourth term and the fifth term all together, I can use this formula right here. Again, I've got my initial value is A. This time I also got to worry about the variable n. I got to say how many variables, how many n's do I have? That would go here. I've got my initial term and then my common difference once again. Whereas when we look at geometric, again, what switched in that quick video? It was talking about common ratios, not common differences, because it's multiplication. So if we want to find the nth term of a geometric sequence, we got to find that common ratio idea. And then what ends up being, whatever number we're looking for, we take away 1 from it, and that becomes our exponent. So if I was looking for the 10th term, I would do 10 minus 1, I would do 9. And then again, because we're multiplying by the first term here, if we remember our exponent rules, like x to the 9th times x is still x to the 10th. So it's just another way to write it. Formula for the sum of n terms. Again, so I don't think right now we don't need this third one, but definitely make sure so that as we move into our practice, you've got these 4 equations written down, because we're going to jump to that next. And You might be kind of stuck if you didn't have the equation. Again, common ratio, my n value, my a. Definitely use calculators on this stuff. So again, whether you use your iPad as a calculator or you have a handheld one, you definitely are going to want that ability. Okay. I'm getting the link pulled up. I will post it in the chat box as soon as I get it. All right, posting in the chat box. Go ahead, click this link. I want everyone in here to be participating. And we'll probably do it for, I don't know, 8 or 9 minutes unless people are finishing up quicker. All right. If you're watching the recording, what I'm going to do is I'm going to share my screen. I'm going to go through the problems, and I would want you to pause the video, try the problem on your own, get an answer, hit play, continue, pause, so that you get to try the same problems that everyone else is. So I'm going to share. Nope, that's not it. There it is. This symbol right here, if you can see on the screen, means you start at the term 2 and you go to the 11th term. So you plug in 2 for x, you plug in 3 for x, you plug in 4 for x. I know we talked about that in the lessons. Awesome. Let's shoot for about 5-6 more minutes. We've only got 5 people in the meeting. I think we've got more than 5 people in the WebEx. Let me double check. Yep. So if you haven't clicked the link in the chat box, I need you to click the link in the chat box. We'll start saying names. I need Jason and Audrey. Abdinas here. Click the link in the chat, please. Okay, just try your best then. We got about 4 more minutes, so you can still get in and do a couple problems before we got to wrap up. I will share those formulas again on the screen in case you need those. Cardon, nice job. If you want to hang tight, or you can change your name slightly and go back in and try a few of those problems again. Someone trying to get in? All right, 2 more minutes. 2 more minutes. Oh, still sharing. All right, finish the question you're on. I'm gonna wrap up soon. Let's see here. We'll go over question 6 and question 10. All right, nice work with that. Let me make it a little bit bigger. All right, there it goes. So if we look at question 6, evaluate this. So this is what I was kind of talking while people were doing it. See if I can share my. So what this means is that we have to take, and now I got to see the problem. All right, perfect. So we're going to add up all the terms between 2 and 11 and see what we get. So it'd be like saying, okay, I'm plugging in 5 times 2 minus 2, I get 8. I'm plugging in 5 times 3 minus 2, I get 13. 5 times 4, okay? And then you go through all of these, dot, 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 you add it up. Now I want to show you a trick, because again, we can use technology to help us. You got to understand the idea, you got to know what's happening, but you can use, it's not the scientific calculator I have, it's the Desmos calculator right here. And if I look under functions, okay, and I scroll, I can see that I've got a Riemann sum right here. And so I could plug that in. Instead of x, it says n. That's fine. N equals 2, x equals 11, and then I type in 5x minus 2, or excuse me, I should probably say n. I'm going to change n to x. And I can see that, hey, it's going to equal 323. And then, okay, so that's cool. Again, using our calculator to help us. Also going to look at question 10. Which formula represents the arithmetic sequence? N plus 6, 2 plus 6 is 8, 8 plus 6 is 14. I don't actually like this question because the first term should be, well, your first term would have to be -4. So -4 plus 6 gives you 2, and then 2 plus 6 gives you 8. Sweet. All right, so again, our class connect. Oh, that doesn't look good. There it goes. Again, just making sure we were paying attention, following along. Take a look at this. You got to match up the equations, okay, or the equations that we had. Again, find those, put them in the correct spots. Again, if it's asking for a sum, it might start with an S. If it's asking for the nth term, it might start with an A. As a hint for you. Otherwise, that's all I've got for you today. Good luck on there was a quiz for this week, I believe. And we will have a class connect next week. So same time, same place. That's all I've got. Have a good one. Adios.